This video is for lesson 3-3 about converse, inverse, and contrapositive. Learning goals are to write and determine the truth of converse, inverse, and contrapositives of a conditional statement, and to be able to write a biconditional statement. All of these words, converse, inverse, contrapositive, are different ways to rearrange a conditional statement. In the last section, we talked about conditional statements have the words if and then, and they have a certain logical order and meaning to them. If we were to switch the order of the sentence, that would change its logical meaning. Every conditional statement has three related conditionals. These are the converse, the inverse, and the contrapositive of that original conditional statement. The converse is formed by interchanging the hypothesis and conclusion of the original statement. The inverse is formed by negating or putting the word no into the sentence for the hypothesis and the conclusion. The contrapositive is formed by interchanging and negating both the hypothesis and conclusion. Here's some examples of this, but these examples are written in symbols. The letter P is representing any phrase of words that we want it to. It's the hypothesis of the sentence. The letter Q is representing the phrase of words that is the conclusion of the sentence. So if the original sentence has the order if P, then Q, and you want to make its converse statement, you would interchange the hypothesis and conclusion. It would become if Q, then P. Again, remember that the Q and the P are the phrases of words that actually build up the sentence. To make the inverse, you put the word no or the word not into the sentence, and it would have the pattern if not P, then not Q. And to make the contrapositive, you're interchanging the order of the sentence and putting the word not into the sentence. It would be if not Q, then not P. Again, with just the letters Q and P, there's not a lot of meaning to this. So let's look at this as an example with actual phrases, with an actual real sentence. If a figure is a triangle, then it is a polygon. This is a true sentence about a figure called a triangle. This first part of the sentence is called the hypothesis. And in the symbols before, that was represented with the variable P. The second part of the sentence, it is a polygon, is called a conclusion, and in the symbols before, that was represented by the variable Q. So our original conditional statement in the table is, if a figure is a triangle, then it is a polygon. Is that true or false? That's true. Any triangle is a shape in geometry that is called a polygon. Let's create the converse of that sentence. We scroll back just a tiny bit. To make the converse, we interchange the hypothesis and conclusion. So we just are going to switch the order of the sentence. It will become, if a figure is a polygon, then it is a triangle. We have interchanged this idea of being a triangle and being a polygon. We've switched the order of the sentence. Let's think about whether this converse is true or false. If a figure is a polygon, that means it has straight sides. Can we conclude it's a triangle? And the answer is false. There are a lot of polygons that are not triangles. So for even just a single counterexample, maybe a square. That's a polygon. That's not a triangle. The next one, we're asked to make the inverse of the conditional statement. So let's scroll back and look at the notes about inverse. To make the inverse, we're keeping the same order of the sentence, but we're putting the word not in both places. We're negating both places. It would look like this. If a figure is not a triangle, then it is not a polygon. Compare this to the original conditional statement. It begins with the idea about being a triangle and concludes with the idea about being a polygon. We still have that same order, but we now have the word not in both places. Is this true or false? If a figure is not a triangle, then it is not a polygon. This is false. For example, we might think of a square. A square is not a triangle, but you know what? A square is a polygon. Okay, the last sentence we're going to create is called a contrapositive. Let me scroll back a little bit to the notes about contrapositive. Here it is right here. To make the contrapositive, we're interchanging the ideas and putting the word not in both places. It would look like this. If a figure is not a polygon, then it is not a triangle. Comparing to the original conditional sentence that started this all off for us, we have interchanged the idea about being a triangle and a polygon, and we've put the word not into the sentence. Let's think about whether this is true. If a figure is not a polygon, so if a figure doesn't have the straight sides that all connect together to make corners, then it is not a triangle. That is true. If a given statement is true, the converse and inverse are not necessarily true, and that was the case in our example. However, the contrapositive of a true statement is always true. And that's what happened in our example as well. The original sentence was true, and we found out that that contrapositive was true. Likewise, if the original sentence is false, then the contrapositive will also be false. Statements that have the same truth values are logically equivalent. Number 2, write a true conditional statement whose inverse is false. We get to make up our own sentence that has the words if and then, but we want the inverse of the sentence to be something that's false. Here's an example. Here's a true sentence that I made up. If you're in this class, then you're a Bridgeport High School student. That's true. But let's think about what the inverse would say. To make the inverse of a sentence, you keep the same order but put the word not into the sentence. It would go like this. If you're not in this class, then you're not a Bridgeport student. That's false. Just because you're not in this class doesn't mean you're not a Bridgeport student. There are lots of students in this building right now that aren't in this class, and they are Bridgeport students. Number 3, let's write a true statement that's logically equivalent to its converse. That means that if we think about what its converse would say, we want it to also be a true statement. How about this? If you are in geometry, then you will learn about shapes. That's a true sentence. Let's think about what the converse of the sentence would say. That's when you switch the order of it. It would be, if you learn about shapes, then you're in geometry. That's probably a true sentence too. When a statement and its converse are both true, they can be combined into one statement if you use the phrase if and only if in the middle of the sentence as a conjunction. This is called a biconditional statement. All the definitions of words from this year could be written as biconditional statements. For example, number 4, let's write the definition of perpendicular lines in biconditional form. Lines are perpendicular if and only if they form a right angle. This is a true sentence, and it's the definition of perpendicular lines. It tells us what perpendicular lines are, lines that form a right angle. Number 5, consider the statement. Numbers that do not end in 2 are not even. Let's rewrite this in if-then form and then state whether it's true or false. If numbers don't end in 2, then they aren't even. This is false because we can think of counterexamples. Hey, how about the number 4? That doesn't end in 2, but it is even. Question B, write the converse and state whether it's true or false. To make a converse, you switch the order of the sentence. It would become, if numbers aren't even, then they don't end in 2. That one's true. If a number isn't even, then there's no way that it can end in 2. Question C, write the inverse and state whether it's true. To form the inverse, you keep the same order to the sentence, but you negate each part. So if we go back to the original sentence, if numbers do not end in 2 and we negate that, we want to say if numbers do end in 2, then they are, the original sentence said, are not even. When we negate that, we want to say they are even. So our inverse is, if numbers end in 2, then they are even. Is that true? And that is true. Question D, write the contrapositive and state whether it's true or false. The sentence is, if numbers are even, then they end in 2. And that's false because I can think of even numbers that don't end in 2. Question E, can you write a biconditional statement for the original? The answer is no, because you can only combine a statement into a biconditional statement if the original sentence is true and its converse is true. In this situation, the original sentence was a false sentence. Here are the check your understanding questions. I'll pause the video for you to solve these. Here on the side are the 4 ways to write that sentence. If an angle is a right angle, then it measures 90 degrees. If an angle measures 90 degrees, then it is a right angle. If an angle is not a right angle, then it does not measure 90 degrees. If an angle does not measure 90 degrees, then it is not a right angle. Notice that these sentences were created by interchanging the order of the sentence and by using the word not in the sentence. Number 7, a conditional statement is true. Its inverse is false. What can you say about the converse and contrapositive? Because the inverse is false, the converse is also false. And I have that answer down here in the bottom corner. Because the original sentence is true, its contrapositive is also true. Number 8, are these 2 statements logically equivalent and explain? If a polygon is a square, then it is a quadrilateral. This means it's a 4-sided shape. So this is a true sentence. If a polygon is a quadrilateral, then it is a square. These are not logically equivalent because in the second case we can have other 4-sided shapes that are not squares. Number 9, Toby says that the converse of the following statement is true. Is his reasoning correct? Here's the original sentence. If a number is divisible by 6, then it is divisible by 2. Let's think about what the converse of the sentence says. If a number is divisible by 2, then it is divisible by 6. That's not necessarily true. There are numbers that divide by 2, but they don't divide by 6. Number 10, consider this statement. All birds have wings. Let's write the statement using if-then form. It might be, if an animal is a bird, then it has wings. This sentence has the words if and this, and it has the same meaning and order as this original sentence. Question B, can you write the statement as a biconditional? For this to be written as a biconditional, the original sentence has to be true, and if you make its converse by interchanging the order, it has to be true. Let's think about what the converse would say. If an animal has wings, then it is a bird. Is that true? That's not true, because we can think of counterexamples. We can think of animals that have wings that aren't birds, like insects. And so because the converse is not true, we can't combine them and create a biconditional sentence using the phrase if and only if in the middle. In this video, we discussed creating new sentences called the converse, inverse, and contrapositive, and then thought about whether these new sentences were true or false. When an original sentence and its converse are both true, it's possible to write them as a single statement called a biconditional statement. These are the kinds of sentences that our book uses for definitions of words.